Hey guys, in this video we will discuss this problem, container with most water. So let's see the problem statement. Given a n non-negative integers a1, a2 to an, where each represents a point at coordinate I, ai. N vertical lines are drawn such that the two endpoints of the line I is at iai and I0. Okay, so find two lines which together with the x-axis form a container such that the container contains the most water. Okay, now notice that you may not slant the container. Okay, see this example one. We have given a height, so we have given this container in this form and the output is 49. So you are given a height of each of the boundaries of the container. So in here, like, you need to consider two boundaries of the container such that it will contain the maximum water. You need to return this area, you can see here. Okay, now the above vertical lines are represented by area, this one, and in this case the max area of water, blue section, the container contains is 49. You have to write algorithm which will give you the maximum area for this one. So let's understand the problem first with some other example. So let's pick this example number 3 with height 43214. So let's draw the diagram for this one. So in this example you can simply tell what will be the maximum area, right? So you can tell this like this will be the maximum area, and what should be the answer here? So max area should be 4 here, and then 4 here, 16 should be the answer. Okay, so how we can write the algorithm to pick the two boundaries for this one. So one more thing before that, suppose you are given some other example where, suppose you are given this example and you are picking this boundary at index 1 and at index 7. So you are not supposed to fill the water like this way and then up to here. Okay, you are supposed to fill, you are supposed to consider only these two boundaries which you have considered for the answer, and then you have to fill till the minimum height of the two. Alright, so this will be the right portion of area. Okay, so we can do this with the naive approach as well, but the constraint given here is n can go up to 10 to the power 5, and in case of this kind of the programming questions, like the computer are allocated only 1 second of the time, and the online judge will refuse your answer if it will exceed of that. So in some cases, like depending on the problem, it can go up to the 2 seconds, but on an average it's 1 second. And to execute the number of the loop, the number of the iteration that can be done in 1 second is approximately 10 to the power 7. Alright, and here n is given 10 to the power 5, but if you will do with the naive approach, you will have to each two loops, and two loops means the complexity will go up to the n square. So n square means it will go to the 10 to the power 10, and since for 1 second we should do only 10 to the power 7 iterations, so it will give us the time limit exceeded error. So let's see first with the naive approach. Now we have two loops, so we can pick the two boundaries here. So first boundary will be height at I, and second boundary will be height at j. So calculate the temp area, not the maximum, which can be calculated as height. You should consider the minimum one, the minimum height from the two. So mean of height at I and height at j. Then we need to multiply with the length, and length will be j minus I. Okay, so this is the current area for what we have chosen, and we can compare this current area with the maximum, and we can update the maximum here. So we can write like max area equal to max area here or the area, so it will update the maximum. Now we can return the result here. It's a perfectly fine solution. It will give the result, but not for every test case. Let's see, try and running it here. Okay, so it got accepted for the example test cases. Let's submit it. So you can see time limit exceeded error. Okay, so we need to optimize this. So we need to solve it with a most efficient way, so that it do not go beyond that 10 to the power 7 iteration. So it should be in the order of ON. So let's see how we can do. So let's consider the first example. Let's make the diagram. So this is the example number 1, which we have given the diagram. How we can solve it? So first, the solution is like, put a pointer here P1 and at the end. Now considering these two boundaries, calculate the area, and if it is maximum from whatever we have stored, then we have to update our maximum area. Okay, now at the next step we need to just convert these pointers. So what should be the rule for converging these pointers? Which one? This one, P1 or P2? So we have a rule like x-axis here is always decrementing by 1. So we do not have to rely on the x-axis for calculating the maximum area. We have y-axis which is changing with every x-axis. Okay, so where we can go? So at point P1 we have the smaller height as compared to the at point P2. So we will move the smaller pointer at the smaller height ahead, in a hope that we will get some bigger height at the next step. Okay, so we will not move this pointer, we will move this one at this position 2. Now we will calculate the area at this position and we will see. So let's do a dry run on this one and then we will see how it is giving me the result. So consider pointer P1 here and P2 at the end. So now considering these two pointers, what will be the area? It will be minimum of height and then the length. Length will be 9 minus 1, 8, and height will be 1. So 1 into 8, that is equal to 8. Now max area equal to 8. Now we will compare these pointers P1 and P2. So since height at the position P1 is lesser, so we need to move it forward. So P1 will move to the index 2. It will be P1 here. So now what will be the area considering P1 and P2? So area will be, what will be the height? P1 height is 8 and at P2 height is 7. So we will consider the minimum one, which is 7 into, what is the length? 9 minus 2, 7 equal to 49. So max area will get updated to 49. Alright, what will be at the next step? Now we will compare P1, P2. So P2 is smaller at this point, so we will decrement P2 to position 8. Now P2 will be here, so area here will be 18. Now we cannot update the max area since it is already 49 and we are getting currently 18. Now since P2 is smaller, so P2 will again move one index back, so it will come to at index 7. And at this point, what will be the area? Maximum height of the 2 is 7 and 7 minus 2 length is 5 equal to 35. We will not update again the maximum area since the area calculated is lesser than the maximum area we have achieved so far. Now from P1 and P2 both are same, so which to increment or decrement? So in this case, if both are same, we can increment either p1 or we can decrement p2, so its result will be always same. So let's increment p1. Now area will be height of minimum of 6 and 7 is 6 into 7 minus 3, 4 equal to 24. We will not update max area. Now height at p1 is smaller, so increment p1 to the next step. Now area is minimum height will be 2 and then 7 minus 4 equal to 3 equal to 6. Okay, now since p1 is smaller, let's move this one ahead. Now area will be height at p2 is 7 and height at p1 is 5, so 5 into 7 minus 5, that is 2 equal to 10. Again the area is smaller than the max area achieved so far. And now so height at p1 is smaller, so we have to increment p1. Now area will be 4 into 7 minus 6, that is 4. So now we have exhausted our search for the area. Now we know we do not have anything to search. So since p1 now in the next step p1 will become p2, so in that case we need to exit from our algorithm. So now we got the maximum area 49 at what location? At index 2 and at index 9, right? So you have to return this 49. So let's see the program how we can do this. So let's initialize a result max area equal to 0 and let's keep a variable area equal to 0. So now what will be the beginning index? 0, right? Since we are given a vector and index start from 0. And what will be the end index? Height dot size minus 1. Now we have the beginning index and now we have the end index. Now we need to search and calculate our area. So till when we will calculate? Till the point when beginning is smaller than end, right? Now at this position what will be the area? At the current position area is minimum of the height of the 2 positions, so height at beginning index and height at end index, right? So this is the height and what will be the length? It will be end minus beginning. All right, so this is the area for these 2 index. Now we have to update the max area. Max area equal to max of max area or area. Alright, now we need to go to the next step. We need to increment or decrement the pointer. So we need to increment or decrement the beginning or ending index. So we can do like if height at beginning index is lesser than or equal to height at ending index, then we can increment beginning in a hope that we will have some bigger height. Otherwise we will decrement the end. So this is similar to height of end is or less than height of beginning. Alright, so in this way this max area will be updated and it will give us the answer. Now let's return this answer. Let's run the code. So test case is accepted. Now submit. Now it got accepted. It took only 80 milliseconds of the time to run, not even any significant comparison to the second. And so what is the time complexity for this algorithm? Since we are running a one while loop and we have beginning and end pointing to the beginning and the end index respectively. So in this case we are at a time we are either incrementing beginning or decrementing end, right? So we are iterating over the array only once, so our complexity is 1 only. Alright, thanks for watching. See you in the next video. Please like, share and subscribe.